All right, so Pascal's triangle. Here we go.
Wait, we're writing down what he's writing down?
Okay. On the note card, or horizontally.
In this video, we'll learn how to draw Pascal's triangle. Now, to begin with, to draw Pascal's...
I gotta hide this so you can see the whole thing. There you go.
In this video, we'll learn how to draw Pascal's triangle. Now, to begin with, to draw Pascal's triangle, the first number we're going to write is a number 1 at the top here.
Right.
Then directly below that, we're going to draw 2 other 1s. This is our starting point. You need these 3 1s in this sort of triangular shape. Once we've done that, we can get started. The idea is to draw the next line of Pascal's triangle, we're going to take the sum of the 2 terms. So in this case, the 2 1s. The sum of 1 plus 1 is equal to 2. So we write 2 below them and in between them. And we complete this line by writing 1 on each end. We do the same thing for the next line. Looking at this third line here, we have 1 and 2, and 1 plus 2 is 3. So we write 3 in between the 1 and 2 on the line below. Similarly, we have 2 plus 1, which is also equal to 3. So we write 3 in between the 2 and the 1, again, just below them. And once again, we complete the line with 1 and 1 on either end. And we carry on this way. To write the fourth line, we can see that we have 1 and 3. 1 plus 3 is 4, so we write a 4 right here. We carry on. 3 plus 3 is 6, so we write 6 in between the 2 3s and on the line below them. And we have 3 plus 1 is equal to 4, so we write 4. Once more, we complete this line with a 1 on either end. And we carry on this way. Looking at the next line, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5. And we mustn't forget to put the 1s on each end. And I'll just write 2 more lines here. The next line would be 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6, and a 1 on each end. Finally, the next line, 1 plus 6 is 7, 6 plus 15, 21, 15 plus 20, 35, 20 plus 15, 35, 15 plus 6, 21, 6 plus 1, 7. On this way, looking at the next line, 1 plus 4 is 5, and a 1 on each end. Finally, the next line, 1 plus 6 is 7, 6 plus 15, 21, 15 plus 20, 35, 20 plus 15, 35, 15 plus 6, 21, 6 plus 1, 7, with a 1 on each end. Following this method, we can draw all of Pascal's triangles. And one of the things we'll be seeing next is how to use Pascal's triangle to help us expand the binomial expansion. Things like a plus b to the power of n. That's one of the main applications that we'll be using this for.
How far down does it go?
It's infinite.
Oh,
It can keep going. It can keep going and going and going. All right, so Pascal's triangle. So someone realized this pattern to help without having to do FOIL over and over or multiple distribution over and over. They recognize a pattern to expand without doing that, right? Now, it's not terrible to do FOIL or box method or whichever one you're most comfortable with. However, after you get to the third power of a binomial, it becomes a little bit ridiculous. It becomes annoying, right? It becomes tedious is the word I think I was looking for. So if you look right here, if I have x plus 0, x plus y to the 0 power, that's just going to be 1. Why is that? Because anything to the 0 power is 1, correct? Now, my second level of my Pascal, well, my first level, because this is your 0 level, my first level of my Pascal is saying I have x plus 1 to the 1 power. What this is telling me is that the power of my coefficient and the power of my variable are both 1. Make sense? When I expand, it's just going to be x and 1. Okay, here, once we got down to here for the binomial coefficient, this is saying your n is 2, your r is 0, your n is 2, your r is 1, your n is 2. This is telling you your coefficients that would be in the place of those numbers with doing the factorial model. Okay, and it just keeps going and going to expanding based on Pascal's triangle. Okay, now what someone then did is they took Pascal's triangle and they created the binomial theorem. Okay, for any whole number n, the key thing is it has to be a whole number, x plus y to the n can be expanded to this format. So what this piece right here is saying, I need to go back to, not that, that's not what it's saying. Oh, no. Okay, if I have c(n) of 0, this is where you had your factorial situation happening, okay? This is saying if you had n of 0, right? And so whatever your n is, it's of 0, and then n and 0, and it just keeps going. This is saying if you had n above 1, that's what your coefficient's going to be. And then the pattern is the degree is going to be less than the one than before. The degree of your second variable is going to be 1 more. And it keeps going and going and going. But what they realize is that if you apply the values of your triangle, you can expand it without having to keep doing n above r, n above r, n above r, n above r to find your coefficients. Does that make sense? Okay. If all else fails, could you do n above r to find your coefficients? Yeah, you could. So you're at 3 right now. So for 3, you would do it. This would be your x cubed. This would be your x squared. This would be your x. This would be your x to the 0. And you would have all of your coefficients for your function. Yes.
Did you guys get it Friday?
No, we got them all last week, but they're in that red basket, like staggered in the baskets. Yeah. Okay. Part 2. So when we simplify this down, we're going to just kind of start with 1. So we have the leading coefficient here is 1. Agree? Well, it's not 1. Sorry. We're gonna do it. We're gonna apply it. So we're on our level 3 of Pascal's. Why am I on level 3? To the third power. So again, this is 0, 1, 2, and 3. So this is going to first tell me what all of my beginnings are going to be. So I have 1 plus 3 plus 3 plus 1. That's what this is telling me. Okay. From there, you then are going to now take your powers into consideration. So I started off as an x to the third. Then my next x has to always be 1 less, correct? So my next x is going to be x to the second, x to the 1, and just for the sake of the pattern, I'm going to write x to the 0. Is that okay? It's really a 1, right? But for you see the pattern, 3, 2, 1, 0. We're good? All right, now you're going to do your constant here, okay? It has to be a positive integer, which is what we're emphasizing. It has to be a positive, not a positive, plus a negative. So this is a -2. So now it's going to be -2, but its power is increasing. So it's going to be -2 to the 0, -2 to the 1, -2 to the 2, and -2 to the 3. And you multiply this out, and that is your answer. Did you see the pattern? It is because you're learning it. But once you get the hang of it, it's not. because you're just saying, okay, here I go. This is gonna be 1, so it's not gonna do anything, so I'm left with x cubed, right? Yes? Okay, now I have -2 times 3 is -6, agreed? Now I have negative times a negative is a positive. 4 times 3 is 12. A -2 times a negative, well, what happens to x to the 0? It's a 1. And then -2 times -2 times -2 is a -8. And there's your expanded. Do we see it?
Yes. Pretty cool.
Do you see the pattern?
I see the light.
Huh? So, but when we're talking about time management, if I have to the 5th,
This will help very.
this will help.
very-
So what I will allow you to do is, like, for testing, I will allow you to use your Pascal triangle. Okay? Yes, to have your Pascal triangle with you. And if you have this to the 5th, you now understand that your powers are reducing for your variables, increasing for your constant, right?
What did the triangle do to help us?
The triangle told us what factors we're multiplying, applying each piece by. So because we were to the 3rd, I'm on the 3rd level. So because I'm on the 3rd level, to find my x cubed, my x squared, my x, and my x to the 0, I'm gonna multiply everything by the first term by 1, second term by 3, third time by 3, last term by 1.
Kind of like what tier you're on and which
It's still this, yeah. So like if this had been x minus 2 squared, we're on level 2, right? So we're at 1 x squared
Okay.
times, and if you want to write out -2 to the 0, right? Plus, now we're at 2x times -2 to the 1, plus, now we're at 1x to the 0 times -2 squared. Yes, these are gonna be just x squared. This comes out to be -4x, and this comes out to be +4. It's for quadratics, yes. But if you're doing it to the 5th, to the 6th, to the 7th,
What do you think is the biggest we'll see? Like,
I'm assuming, I would like to say no, nothing past the 6.
something about the six.
I would assume.
So it's like, if it's like 10, that's not manageable. You might need that,
Yeah.
like, that's still gonna take forever.
I think it would be, I don't think it would be any more past the 6.
Exactly, that's why I'm like.
Yeah, I think it'll be a little bit ridiculous if they made you do it that far. Because what level did our Pascal's triangle stop at?
We started at like.
7, right?
Stop at 7.
7. So I would anticipate it not going any higher than that. All right,
This was the blue or red.
which one? So the
Blue is this example,
Okay.
and then she asked, how does it look with a